Thanks for coming today. So today I'll be discussing the economics of carbon markets for dairy industry with a special focus on Washington's dairy industry. I will admit discussing carbon markets right now is a little challenging given the state of the economy, but nonetheless, we have dairy cooperative initiatives going on within the state of Washington. About 70% of Washington's dairies are under Dairy Gold, with Dairy Gold having its zero targets. We also have the state of Washington with its climate mandates. So I'll discuss today how those are interacting and what the potential challenges are there. So just a brief overview of my presentation. I'll discuss the types of carbon markets just to get us all on the same page. Then we'll go into the state greenhouse gas mandates within Washington, as well as industries and, like I said, the potential challenge there to address both of them. Then I'll discuss some of Washington programs and some farm level research going on right now to answer some of our big questions around this will all play out. Then I'll describe the economic modeling that I do to try to understand, the level of greenhouse gas reduction we might expect to see from Washington's dairy industry, and the level of investment that the state will have to do to see those reductions, basically. Then we'll interpret some of those results and wrap up. So the types of carbon markets that I'm discussing, regulatory and compliance markets. First, we have cap and trade programs. California and Quebec have their market that's been on over a decade. Washington has a cap and trade, or called cap and invest. That market is expected to link to California and Quebec's later this year. Then we have state clean fuel programs, with California's being online for a little over a decade. Oregon has been on since 2016, and then Washington in 2023. All of those are functioning separate right now. Then we have a federal renewable fuel standard. This is the RIN right now, where dairy biogas to RNG projects are able to earn that RIN credit. I would say the state clean fuel programs and the federal RFS program are really what have supported the digester projects in California. We have close to 100 to 150 earning dual credits under the state clean fuel program and the federal RFS program. Really, those are key factors to their success. The markets, these are things like corporations voluntarily reducing their greenhouse gas emissions through purchasing insets. Insetting is becoming more of the trend as corporations, like you might have heard earlier, are being accused of. So doing an inset is a little less risky compared to purchasing an offset. Nestle is doing this right now. They purchase carbon credits from a couple dairies within their chain in Washington state. So our state climate mandate and industry sustainability initiatives, the carbon markets I just mentioned are basically being used as a means to help the state as well as industry reach their climate goals. Washington, they're really looking at the dairy industry in the state and seeing what can they do to reduce their emissions. There's no mandate specifically on dairy to reduce emissions like in California. But we did just have a bill that came up at this legislative session that would have required greenhouse gas reporting on dairies of all size, even a one cow dairy. That's been making producers squirm quite a bit as to what the state might be expecting of them come, a few years down the road, creating some uncertainty there. Then we have dairy cooperatives like Dairy Gold with the net zero by 2050 target. One thing we do know right now is that if we have a dairy with a digester that is selling into these state programs, earning credits through the clean fuel program, the industry cooperatives like Dairy Gold cannot also claim those greenhouse gas reductions. And so we're not too sure where that leaves producers. And so the state of Washington, through its CAP and Invest program, has funding for dairy digester research and development, as well as our alternative manure management practices, very similar to California's DDR-DP program. We're trying to do the same thing in Washington. Um, right now, research is being funded by this funding source under what's called the Climate Commitment Account. There's a project being led by Washington State University and Nutrient. I'm a collaborator on the project, but it's basically looking at the carbon intensity of farms of various size across the state. Um, the deliverable, the study will be finished by this summer, but it's looking at what can dairies do to reduce their carbon intensity and have a list of practices that they can implement to get them to a specific carbon intensity. Both practices um, that are eligible for carbon markets as well as those that are not. So I especially um, the practices that are eligible for carbon markets. So I get asked the most about the cap and flare system. And so I'm just going to run through how I set that modeling up and how it helps me inform the state on, you know, the level of greenhouse gas reductions that can be achieved from them and the size of farm that they're at. So one of the first things I do is look at the prices in the markets, obviously. For the cap and flare, you're looking at either an offset price or an inset price in theory. Um, so yeah, that would be through the cap and trade programs. We don't have a project, dairy projects participating in that right now, but it is an option. Um, let's see, for the biogas to RNG projects, like I went over, we have the state clean fuel program as well as the federal RFS program. So uh, picking the prices within the model to help us in our projections. The second step is estimating biogas quantity. For the cap and flare projects, there's some models out there, the livestock offset protocols that can be used. That's what I use for that particular project. And then estimating biogas quantity for biogas to RNG. I've worked with some private developers and engineers to build out models to estimate, based on cow numbers, basically the biogas output there. And then the system cost. This is where it gets a little tricky, especially digesters, they can be a little complex. So really looking at parameters that aren't going to change a lot. Um, yeah, it's something I spent quite a bit of time on for the digester side, which I'll go over more in a second. Um, so going a little more into detail on where we plug the prices in and doing our revenue forecast. Um, the cap and flare project, just one revenue source right now, which is I have an offset price of $10 per metric ton of CO2 equivalent. But really, the annual greenhouse gas reduction needs to get plugged in there, which is the difference between the baseline emissions and the project level emissions. And then for an AD project, we have three revenue streams. I mentioned the carbon markets, but then they can also earn revenue through the commodity gas price. So I went with the current LCFS price, which is around $61 right now in Oregon's market, and then 240 for a D3 RIN price. Um, use the negative 200 CI score. I didn't touch on the CI score, but that's a really critical piece of all of this. Each dairy biogas project is assigned its own CI score. Uh, there has been some, I guess, effort by environmental groups lobbying to remove methane crediting for the model that creates the CI score. Um, in some ways, it's been successful, but that would have some pretty big implications, I think, long term, especially Washington, if that was successful. Although I think, in the next several months on if Washington's clean fuel market is going to honor that avoided methane crediting and how that will play out. Anyway, 268 for the commodity gas price is what I used. Not going to spend a ton of time. Um, that you, I worked with a private developer, like I said, for the projects. You're looking at a project minimum of about $12.1 million. It ranges anywhere from $4,400 to $5,900 per Holstein cow wet equivalent. For this model, I use the $5,900. So on the higher end, just to kind of account for the current conditions in the economy. Um, and then covered lagoon and flare. NRCS has some cost practice scenarios for 2025. I just went with that. It's about $484 per animal unit and about 485,000 for a project max. This is an overview of the net present value model. I take the revenue and the cost estimates, plug them into here. Basically, it looks at the sum of the cash flows over the lifetime of the project. I use a project lifetime of about 15 years typically for AD projects. Discount rate of 5%. That's pretty typical for agricultural investments. There's definitely some risk in using a model like this because you're assuming the same price over the 15 years, which is just not the reality. These LCFS prices, they probably are the most volatile. So taking that into account, but it basically, if the net present value is positive or greater than zero, the project might be worth investing in. So from a state level perspective, that just kind of helps us see, when these things start to become feasible. So results for the covered lagoon and flare, my model shows that you need at least 1,500 mature cows based on the $10 per metric ton offset credit price. This represents 15% of Washington dairy farms. Let's see, for biogas to RNG, my model shows that you need at least 3,000 mature milking head, representing about 8% of Washington dairy. Wait, eight only covered lagoon. Um, Percent overestimation. When I worked with private developers in the state, they're really 5,000 cow farm actually represents only 4% of Washington. The covered lagoon flare, yeah, that might be a little bit of an overestimation, but some, like I said, when start to become economically feasible. My model did not take into account cost share. In California, cost component to the startup of their 100 to 150 digesters. We hope to see that same level of investment happening in Washington State, but it's it's been a little complicated getting that cost share program off the for a number of different reasons, but it's the hope that adding that we'll be able to see adoption at farms of smaller scale in theory. But system cost remains a huge constraint to all of that. I think the model shows, though, still that carbon markets are only feasible for the largest of farms right now. Um, One thing I want to mention is the federal E-RIN. So this is similar to the RIN, but it's for biogas to electricity projects. Federal E-RIN is not available right now for dairy digester projects. I do hope that that will come online in some world in the future. Um, it would really help get those projects off the ground. Biogas to electricity projects have lower levels of lower requirement of capital investment that go into them. They're cheaper, basically. So that's something we hope to see. And I believe the consensus is that smaller scale producers will have to look to non-carbon market approaches to reduce their greenhouse gas emissions. So adding things like separators, um, you know, keeping solids out of their lagoon, maybe looking at enteric fermentation, inhibitors, that kind of thing. And that's it. Just going to do a shameless plug for a podcast I did a couple of years ago now with Washington State University and U of I talking about carbon markets. So go ahead and check that out if you get some time. Thank you.